Good morning.
Good morning, teacher.
Welcome. Today we are going to look at the scientific method, which we've reviewed a little bit already. And if you'll turn up here, we have the scientific method. You can also look at your notes. So, the first part of the scientific method is asking a question. Asking a question. Now we could ask questions of just about anything. We could ask, why does the door squeak? We could ask, why does my foot hurt me when I step down? We could ask, why does the corn grow taller when I give it fertilizer? And today we're actually going to look a little bit more at that question. So, our question today is, why does a corn grow taller? Or what is the effect? That's a better question. What is the effect on fertilizer on corn growth? Was anybody here with me last week, a few weeks ago, when we went out to the farm? Yes? We went out to the farm and we put fertilizer on the corn that had just been planted. And I've been wondering, how much of an effect does that fertilizer really have? So our second step to the scientific method is to do our background research. Now we know that it's recommended that we put fertilizer on corn. Does anybody know what's in that fertilizer? Can you say it louder? What do we have? Nitrogen, potassium, and aluminum? There might be some aluminum. We have nitrogen, potassium, and phosphorus. There's also many other minerals in the fertilizer as well. Sodium? There might be sodium as well. You'd have to look specifically on the fertilizer bag. So, we know that there's a lot of great minerals that will help the corn grow. And now we're going to construct a hypothesis. Now if you remember the word hypothesis is a statement, not a question. So here we have our question, what is the effect of fertilizer on plant growth? Now we're going to turn that into a statement. And sometimes it's called an educated guess. This statement is not necessarily a guess because we base it on some of our background research, which we know that we could know personally, or we could look to our textbook or the library for other resources. Even the internet is a great resource too. So, a statement, not a question. It has to be testable and measurable. That means that we have to have results that we can see. And finally, it needs to be a clear, specific experiment. If there's too many variables in our hypothesis, when we go to form our experiment, it's going to be very difficult to find the testable or measurable outcomes. So, the hypothesis that we have today is that the application of fertilizer is going to increase the rate of growth in our corn. The application of fertilizer will increase the rate of growth in our corn. Next part of the scientific method is that we're going to test this with an experiment. And our experiment is directly related to our hypothesis. If we think of experiments, we don't want too many variables. We want to have a direct relationship between cause and effect. So the experiment that we're looking at today is, let's pretend this whole classroom is our cornfield, and we're going to put fertilizer on half of the cornfield. And we also have the other half that does not have any fertilizer on it. We want to make sure all the other variables are held the same. So it's in the same area, it receives the same amount of sunlight, it receives the same amount of rain, same amount of weeding. So everything is the same in this field except for the amount of fertilizer that we're putting on the corn. So one half has corn, fertilizer on the corn, and the other half does not have fertilizer on the corn. Understand?
Yeah.
Yes?
Yes.
Okay, so now we have an experiment. Our experiment is established. Oh, one moment. Okay. Have our experiment, and now, what do we do for our experiment? We're going to have the students in the class go out every day and measure that corn. They're going to make sure that they always take it from the same plants throughout the field. And remember, we want to have as many variables the same as possible. And then they're going to measure that and they're going to record all the data. So when we're recording, we want to be very accurate. We want to make sure that we're being very careful with our data, because that data now is going to go to our results. So the next step is analyzing our results. And what has anybody here made a chart before? Have you seen a chart? Yes? Yeah, so we might have something that looks like this. Let's look over here. Now, what is our predicted trend with this fertilizer? Will it be faster or slower than no fertilizer? Will it be faster or slower than with no fertilizer? Go with what? We still have growth, but what do you think?
I think with fertilizer it will be fast.
With the fertilizer it'll be faster?
Yeah.
Okay. Well, we haven't actually done this experiment yet, so we can't say for sure. Our prediction and our hypothesis says that we believe that the application of fertilizer will affect the rate of growth. And once we're done with the experiment, we're going to analyze our results and actually determine if this is true. So a great way to look at your results is to create a chart or a graph of the data that you're analyzing. And this could be done for anything. It doesn't have to be fertilizer. It could be done for any experiment. Okay. Almost done. We have analyzed our results. We're going to look at the chart. Let's say every single one of these was just a little bit higher than no fertilizer. Okay? So here we have our draw conclusions, which we look back to our hypothesis, right? So when we draw conclusions, we need to either accept or reject our hypothesis. If we have inconclusive results, or it was totally incorrect, then we would reject our hypothesis. However, in this case, we are going to say that we accept our hypothesis that the application of fertilizer positively impacted the rate of growth in our corn plants. So draw conclusions. It's either yes or no. And it's either all yes or it's no. Because if part of our conclusion didn't support our hypothesis, we'd have to reject it and go back to the drawing board. So if you want to draw in your notebook here, draw this arrow from draw conclusions back to constructing a hypothesis. Because for many scientists, it's a cyclical process where most of the time they might not ever have a hypothesis that is fully supported. And so therefore, they have to go back to the drawing board, maybe alter their hypothesis, do a new experiment, analyze the results, and do the whole process over again. Okay, so now we've drawn our conclusions. We say yes. Say yes.
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 We are going to accept, based on our data here, that our hypothesis is true, and now we can move on and report our results. So we mentioned before that our report may be personal and maybe for a teacher, for a classroom. It also could be in a journal of science. And when people are scientists and they're working in their lab and they're studying intensely on a specific subject or a question that they have, they often write about their trials and their experiments, and then they report their data to a journal, a science journal. After that data is reported multiple times, we move on then to just more conclusive ends, and it's published in other books, such as your science textbook or other journals online, or anywhere. Okay. So report our results. For this, what you might do is write yourself a lab report based on your whole experiment. And your expectation for a lab report is that you would follow through the scientific method. You would show us what question that you asked. You would outline some of your background research. You would construct a hypothesis. You would show us how you came to that. And then you're going to show your experiment. You're going to show us what you needed, how you constructed it, the variables that you had, and then you're going to show us your results. And in this lab report, it's always going to be written very neat and professionally, and you want to be able to then communicate this report, your results, as part of communication. You're going to communicate your findings. Even if your hypothesis was rejected, you're still going to communicate and maybe explain where you think either things went wrong or why you think that your hypothesis was not accepted. Okay, are there any questions? Yes.
Like you always use, in your country you always use this in address like ours.
Do we always use this in our country?
Yeah.
Definitely. We start learning this in the middle school ages, and it's something that you can use not just in class. You can use this for anything. Ask yourselves questions, and it's just part of that problem-solving process. It's a really great tool to problem solve and to think critically about material and about the world around you, really.